This is just a quick video about this interface board that I've made for the Omnibus, which is what's used in this PDP-8F. It's just going to be a short video. There'll be very little explanation. I was going to make it just private and provide a link to it in the VCFED forum for vintage computer enthusiasts, but I haven't put out a video for a while, so and it may be of some general interest, and so I'll publish it, but I won't go into the sort of more detailed explanations that I try to do normally. So we'll just rush through it. Yeah, it's this thing, which is a homemade single-sided board. So it's all SMD on the top and a lot of wire links on the bottom, and I connect it to the Omnibus with these adapter boards I got made, which are double-sided because the connectors are double-sided. There's 18 contacts per side, so 36 there, another 36 there, and there's 4 of them altogether, so 72, 144 connections altogether. And these adapters, when they've got these connected to them, these connectors take the double-sided Omnibus and make it single-sided here, so I can get to everything. So I'll describe that in a sec. I'll just mention a bit more about these. These things have turned out to be quite useful. I mean, they're good for enabling a single-sided board to be connected to the Omnibus, so I can make a quick prototype at home, although this one took quite a while, especially with these wire links, which I'll never do again. I'll always try and do a double-sided one if it's this complex in future. Less complex one, I don't mind, a few wire links, but this one was ridiculous. We can do things like, I've made this little power voltage monitor, just a couple of plugs that go into one of these connectors, and I can monitor the voltages on the bus. In fact, I'll do that now. And there it is. It's got to be in those 2 slots. It gets the 5 volts out of this slot, and the plus and minus 15 out of the 3rd slot, the 4th slot rather. So, and that goes to this little thing. I'm going to turn on and look at some voltages. And I'm mentioning this because part of the function I've put in on this is voltage monitoring. So I want to check what the suppliers say on this meter, and then we'll see what this thing says. So this should be minus 15, okay, minus 14.77, plus 5, 4.8, plus 15 is pretty good, just a smidge over 15.09. Now I know that this board reports the minus 15 at quite a bit lower than 15, so 14.78, so there's something obviously wrong with the way I'm measuring the voltages, but anyway, now we know. And another use for these gizmos I found quite useful is if you have, I've got a couple of extender boards there, so if I want to look at a particular signal easily with the oscilloscope, instead of trying to get down there with the extender boards, I can just put, it can only either be in these 2 or those 2, it can't sit across these 2 because the gaps, this gap here is smaller, so it's got to be there or there. And then with little things like this, I can put that in there, the side that I need to get to the signal I want, and by leaving out, because these things have 40 pins and there's only 36 on the connector, 4 of them aren't used, and with this little cheat sheet I can see they're the 4 that aren't used, and they're the pin numbers for the rest. And if I also have a missing pin in those things that I stick in, it's easy to find the pin I want. If I want, say, L2, okay, that's on the 2 side, L is the 3rd last one in the middle block, so it's that pin there, 3rd one from the end. Easy. Alright, enough of that. Let's have a look at this board. Obviously an Arduino Nano. This design is sort of a mash-up of a couple of other designs on the web by a couple of other VCFED residents, Malcolm Macleod and Roland Huisman, I hope I pronounced that right, Roland, which have a bunch of shift registers, 1, 2, 3, controlling drivers onto the open collector drivers onto the Omnibus. So it can put data out by loading those shift registers with something, and then these open collector inverters put it onto the Omnibus. These other 3 chips are also shift registers, but they take signals from the Omnibus and allow it to be imported, read into the Arduino. And in fact, there's 4 of those. There's another one up there to get some more signals. And then a bit of other logic, which I'm suspecting I don't really need, but I'm using it at the moment. But yeah, it could be that I don't need that stuff. So let's plug it in, and I'll show you the software I've got going with this. So there it is. Is it plugged in? No. Plugged into the computer, so there's little lights on, and turn on the PDP. Okay, here's my software. This is a slightly older version because I'm struggling with the communications between these two things, and I'm trying to do it a better way. And that's not ready yet. It looks like it's going to be a while. So let's turn on the PDP. Connect to it. Do that. Now, this thing is for interacting with the memory. It can also control stop and start programs, but it's mostly about interacting with the memory. First of all, just to look at it like this, let's download the first 4K. We can clear it and then see that it's all zeros, or we can put a number in it. All twos, 4,096 of them, and then load the field. Look at the lights on the PDP and see it counting through the addresses. So we filled up the first 4K, and we can look at the next 4K. Now, I'm not actually sure how much is installed in this thing. There's at least 8K. No, I'm not sure how much memory's in this, so forget about the other fields up to 32K. We'll just look at the first 4. Go back to 0, load the field. Yeah, so we didn't fill this field at least, but okay, fill, and now load. Yeah, clear it. So we can do that with memory. We can look at memory with that, and the other main function of this is to easily get programs into it. And I've got a small selection of programs. These are all this stuff's all contained in a file that is easily edited, and like increment accumulator, and the only things that really matter in this are that first address, which tells it where to load it, and it's also the start address, and the instructions to stick in sequentially after that. These addresses beyond the first one don't matter. So, and we can tell it to run on load, so download, and if we watch the accumulator over there, it's incrementing the accumulator. And I can send a command H, which means halt. I should have a stop and start button, and I'm working on that. Back to programs, memory filler. This uses the computer to fill its memory rather than the Arduino. So obviously it can't fill all the memory because it's got to live somewhere in it. But let's put in 4321 as the fill pattern, and download and run it, and then go to memory and load the field. And we've got 4321s, but not everywhere. So, and this here is parts of the program there, but have we got a ghost copy here? Is there something wrong with my memory? I'm not sure. All things to look at. Download it again. So there's our program, and if we set the address to 0 and then say run, I'll give it say run, it runs it again. And if we look at the field again, It looks like it's wrapped around and clobbered the first location. Another program, let's see, we've got this Cylon thing. That didn't work so good, did it? Let's try the good old increment accumulator again. That's working. Halt. There's another one that lives at 0. This one lives at 5555. So watch the address lights up the top, they'll be different this time. So download and run it. So now it's running, but it's got 55s in the addresses. Stop that. Try that Cylon program again. Yeah. I think it relies on the accumulator being clear when it starts, and that's why we're getting that nonsense. Anyway, so there it is, a quick look at what I've been trying to do here. There's a lot more I want to do with it, and a lot more polishing needed. You know, I'm pretty happy with what I'm able to get going with that little board so far. Hope you enjoyed. Give it a like if you did. I haven't given much explanation here. I'm assuming you know what the hell goes on inside of these things. So for people who aren't from the PDP fraternity, you may think this was a bit weird. Oh well, catch you later.